In this video, we're going to use matrices to solve a system of equations, and we're going to finish solving our coffee problem. So we're going to solve this system by creating what's called a matrix. A matrix has rows and columns. It's a rectangle, a rectangular array, and we have numbers in a matrix. These are called the elements. So we're going to look at this system here. Notice that it's similar to our two equations that we wrote for our coffee problem. It's just a little bit simpler because we don't have decimals and numbers in thousands. We just have simple one-digit numbers here. But we have two equations, and we have a number in front of x, we have a number in front of y, and it equals a number. So with this system, we have two matrices, the coefficient matrix and the constant matrix. And you should be able to look at the system and the matrices and identify where the numbers are coming from. So the coefficient matrix is coming from the numbers in front of x and y. And notice that this is a -3 because there's a negative in front of the 3 that's in front of y. So we have 2 in front of x, -3 in front of y. And notice also that the positions of the numbers are not changing. So I can't just mix the numbers up. I have to put them visually in the same spaces that they are in the equations. We have a 1 here in the lower left because there's no number in front of x. So you might remember in that case there's like an imaginary 1 here. So the coefficient matrix is the numbers in front of x and y, not the x and y themselves, just the numbers. The constant matrix is the numbers that are on the other side of the equal sign, the numbers that are by themselves. So we have a 5 and we have a -3. And again, I need to maintain the same order that I have in the equations. So this top equation here is the top row of the two matrices. So I have the 2, the -3 on top, and I have the 5 on top in the constant matrix. So those are two matrices that I can write for that system. Now we're going to write the matrices for our system with the coffee problem. So first we're going to write the coefficient matrix. I'm going to pull the numbers in front of x and y in my equations. So 0.75 and 0.375, 0.25 and 0.625. And I set this up in Word so that you should be able to type these in. You could also handwrite them. If you are printing your notes or whatever is easiest. So 0.75, 0.375, and then we have our second row is 0.25, 0.625. No x and y, just the numbers. And then for my constant matrix, that's going to be the two numbers on the other side of the equal sign, 6,600 and 5,280. So I'm going to type those in. Now we're going to go to Desmos.com and we're going to use the matrix calculator. So on the Desmos main page, under Math Tools, we've used the graphing calculator and the scientific calculator. Now we're going to use the matrix calculator for this. So click on that. You see it looks somewhat similar to the scientific calculator, although there's some differences on this left side. So what we're going to do is click New Matrix and enter the coefficient matrix, and this is going to be matrix A. So I'm going to do that here. Click New Matrix. You see the A pops up, and you see that it's already a 2x2 matrix, so I don't have to adjust the size. I just need to type in my numbers here. And then once I have that set up, I can hit enter on my keyboard or the blue arrow enter button here to enter that matrix. Next, I'm going to enter the constant matrix, and we use the plus and minus buttons to adjust the numbers of rows and columns as needed to make the matrix, and click enter on that. That will be matrix B. So we see here, we click on New Matrix again, it brings up matrix B, and this is where I can edit the size. I only want one column, so I'm going to subtract a column to make it just one column. And then I'm going to enter my two numbers here, and then click enter to enter the matrix. And then the next step is to type a to the -1 power b into a new row on the calculator. So when I do this, that -1 actually means inverse. We're not going too much into detail on what that actually is in terms of the matrix here. We could spend a lot more time on this, but we don't really have the time. So in terms of entering this in, I just hit the A, or I can type capital A. This is the A to the -1 button, so that puts the power of -1 on the A, and then I just hit B. It's actually times B, but I can just put the B next to it. And then my answer comes up here on the right side. So you can do this by hand. It's a lot of steps. It's a lot of work. The Decimals calculator is a really nice shortcut in terms of not making you do all that work by hand. So we have our answers here. Our top number is X and our second number is Y. And so going back to remembering what X and Y actually are in this problem, X is pounds of the robust blend and Y is pounds of the mild blend. So what I have here is 5,720 pounds of robust blend and then my second number, 6,160 pounds of mild blend. And then finally, question 8 says to check your answer by graphing both equations and looking for the intersection point, and then paste the link or image of your graph. So I did this already to save time, since we've already talked quite a bit about graphing. Notice I have the equations typed here on the left side, just typed the same way that they are up in where I wrote them. So these equations up here. And then setting my window so that I can actually see where the graph is. There's my intersection point. If I click on it, I can see that the coordinates are the same values as what I found in my matrix, 5,720 and 6,160. So that shows that my answer is correct. I could also solve the problem by making the graph on Desmos. Instead of using the matrix calculator, I could just type these equations in here and then look for the intersection point. However you want to solve the problem, either way is fine, as long as you can get the right answer.